Today I'm going to do a general review of Unit 2, multiplying and dividing integers. I will start with the modeling methods for multiplication. For example, if I have positive 6 times negative 2. When the first integer is positive, it's much easier for you to model. You're thinking put in, when it's positive, put in 6 groups of negative 2. So putting in 6 groups of negative 2 tiles, I've got negative 2 tiles, 2 shaded in tiles, and I want to put in 6 groups like that. 1 group, 2 groups, 3 groups, 4 groups, 5, and finally 6 groups of negative 2. They all should be shaded to signify the negative sign. If I count up how many tiles total I have 12 negative tiles. My answer is negative 12. I could always check this answer as well with the sign rule. My signs are different, so I expect a negative answer. 6 times 2 is 12, so it's a good check for you. When it becomes more difficult to model the multiplication is when both of the integers that you're multiplying are negative. Normally, if one is positive and one is negative, you can reverse the multiplication, because remember, multiplication is commutative, meaning I can flip the two numbers and I can multiply them in the opposite order. When they are both negative, however, you can't do that. You can flip them, but it's not going to make your life any easier. When the first integer is negative in modeling, we think of take out 6 groups of negative 2. Now I need to take out 6 groups of negative 2 tiles. As you can see on my board, I have no tiles to take out, so I have to add some in. But if I add some in, I'm going to change my answer here. Right now I have 0 tiles representing 0. I need to make sure I start out at 0. So although I want to take out 6 groups of negative 2, I'm going to draw in 6 groups of negative 2, but along with those 6 groups of negative 2, I'm also going to draw their positive parts. So that I'm creating 0 pairs, or I'm using the 0 principle, if you refer to it as that. I'm making sure that I've got just as many negatives as I do positives, so that this still represents 0. I'm still starting with 0. To take out 6 groups of negative 2, I need to take out all of the groups that are drawn of negative 2. So taking out the 6 groups of negative 2, I'm showing them just as going out of my picture with the arrow. What's left is my answer. And I count up, I've got 12 tiles there, they're all positive that are left. So I've got positive 12 as my answer. So you can quickly check this as well. Signs are the same, so I expected a positive answer. 6 times 2 is 12, so it's a good check. If one of these integers is positive, you can stick to the put in model, but if both are negative, you're going to have to use the take out tiles model. So what I would like, if you would like to pause this video right now and try out a problem on your own, I will put up a question here from each of them.
Ms. Kosh, can you call 1025, please?
I'm going to have positive 5 times negative 3. So if you'd like to pause the video and try this on your own, and then check after I do it. So, positive 5 times negative 3, I've got a positive integer. That means I can put in 5 groups of negative 3. So I'm going to put in 5 groups of negative 3. 1, 2, 3 negatives, and I'm going to do that 5 times. I'm putting in 5 groups of negative 3. And remember, the negative tiles are shaded. I count up how many I have total. I've got negative 15. Okay, so if you want to check your answer there, I will also do a negative one for you to try. So if you'd like to pause this video, and I will give you a negative multiplied by a negative question. So we've got negative 3 times negative 4. So if you'd like to pause the video and try this on your own, then I will model it for you. Negative 3 times negative 4, there's no point in trying to switch the numbers around. They're both negative. You're going to have to take out so many groups of your tiles. This reads take out 3 groups of negative 4. So I'm going to take out 3 groups of -4. I don't have any tiles here to take out, so I'm going to add in 3 groups of -4. But remember, if you're adding in tiles to start out with, you must also add their positive parts. So I'm drawing in the unshaded tiles as well, so that I've still got 0 to start out with. Now I can go ahead and take out the 3 groups of -4. I take out the 3 groups of -4, what's left is +12 tiles. And you can check that again, sign rule, same sign, get a positive answer, 3 times 4 is 12. Okay, so you can use your sign rules to check, but again, this outcome stresses the importance of modeling, that you can represent this multiplying and dividing integers using models. So that is multiplication for modeling. I would also like to quickly show a couple dividing questions for modeling. If I'm going to divide, for example, +12 divided by +6, then I need to think of 12 positive tiles divided into +6 in each group. So if I've got +12 tiles and I need to put +6 in each group, that's fine, they're the same colored tiles. So I'm going to put 6 positives in one group. I haven't used all +12 tiles, so I'm going to have to make another group of +6, and I see that I've used all +12 tiles. How many groups do I have here? I have 2 groups. And again, we can't have -2 pairs of socks, so this must be +2. And again, you can check with your sign rule, same sign, so +12 divided by 6 is 2. The one that becomes a little bit difficult is when the signs are different. We only have one strategy for signs are different. If I'm thinking -16 divided by +4, if I think of this, I have 16 negative tiles. It doesn't make sense to start drawing groups of +4. If I drew +4 tiles here, that's not representing these -16. So instead I must think of this as I've got -16 tiles divided into 4 groups. Instead of groups of +4, I'm thinking +4 groups. So I draw 4 groups, and I start splitting up my -16 tiles. Now I can quickly tell there's going to be at least 2 negative tiles in each group, and I count that up. I'm only at 8 negative tiles, but I've got to use 16, so I'm going to add in 2 more. You can add them in one at a time if you need to, just to make sure you get the correct answer, but I can quickly check here. I've used all 16. There were -4 in each of my groups. My answer is -4. So again, notice that I'm thinking of dividing into that many groups instead of that many tiles in each group, because I didn't have positive tiles to start with. So again, if you'd like to pause the video, I will put up a quick question for you to try out, and then you can check your answer. So let's try -16 divided into -8. So pause the video if you'd like to try this on your own. Again, my signs are the same. I can think of this as -16 tiles, and I've got to put them in groups of -8. It doesn't make sense to divide them into -8 groups. We don't have anything that makes sense for negative groups. So I'm going to put -8 tiles in each of my groups. I've got -8 here. I haven't used them all up, so again, I've got to do -8 more, and I see that I have 2 groups. And again, that's +2 groups, so I get +2. If the signs are different, okay, so if you'd like to pause the video again and try this one on your own, when the signs are different, try +25, we'll actually make that -25 divided by +5. So pause the video if you'd like to try this on your own and then check your answer. I've got 25 negative tiles. It doesn't make sense to start drawing groups of +5 because I have positive tiles here, but I'm starting with negatives. So it makes more sense to take my 25 negative tiles and divide into 5 groups. Again, +5 groups makes sense. So I draw 5 groups, and I go through and I sort all negative 25 tiles into each of these 5 groups. Okay, so I can quickly tell that there's going to be 5 negatives in each group. If you need to do one at a time, that's completely fine. Go at your own speed. But again, make sense of your answer. There are negative 5 tiles in each group, so my answer is negative 5. I'm not thinking of negative 5 groups. I'm talking about how many tiles are in each of these 5 groups that I've made. There are 5 negatives. Again, you can check with the sign rule. Negative and positive signs are different. I get a negative answer. 25 divided by 5 is positive 5. So it's a quick check. Throughout this video, I've talked about the sign rule, so I'm not going to cover the sign rule again. Again, with multiplying and dividing, if the signs are the same and you're dividing or multiplying 2 numbers, then you get a positive answer. If the signs are different, you get a negative answer. That rule does not work with addition and subtraction. If you have negative 3 tiles plus negative 4 tiles, you have 7 negative tiles total. You do not end up with positive 7. Okay, so again, I need to stress that. What I do want to show you quickly is writing a quotient statement to a product statement or vice versa. If I've got negative 5 times positive 3, this equals negative 15. But I can also write it backwards as a quotient statement. Negative 15 divided by positive 3 equals negative 5. So we can write the product statement as a quotient statement or the quotient statement as a product statement just by reversing the order.